Hello, welcome to our discussion about the intersection between design and technology at Polish Tech Day. My name is Marcin Kosicki, and I'm an associate partner at Foster & Partners in the Applied Research and Development Group. I'm joined by my wonderful guest, Adrian Kreinflick.
Hello everyone.
Hi. So I'm super excited because Adrian is a researcher at the Faculty of Architecture at the University of Porto, and also a co-founder of Dosta Tech, an engineering company, and he studies generative frameworks in architecture. So Adrian is also a true nomad who graduated from the Technical University, in which worked in one of the biggest names in the architectural industry, like Zaha Hadid in London, and for Fernando Romero in Mexico City. He's run over 150 workshops all over Europe, basically, traveled a lot. He's a senior lecturer at SWPS University in Warsaw and was a visiting assistant professor at the School of Art in Design in Berlin. So we're going to talk about design technology. And I know from my personal experience that this topic is not that well published and known for people who are outside of the design community. People in the general public might be familiar with property technology and construction technology, but not that well with design technology. And Adrian, since you've had so much experience and exposure all over the world, what's your take on it? How do you define design technology?
I think what we need to first of all, hello everyone. I'm really glad to be here. I think it's a great opportunity of meeting everyone. Well, at least online. Well, the question is quite simple, quite complex at the same time, because I've been asked this question a couple of times or many times, and this is also a question of the tools that architect or designer or we have basically. So this is about this change that happened in last 20-30 years, that we stopped drawing by hand. We start using first off we start using computers as very simple drawing machines. So we were in this kind of mimicking what we have been doing beforehand. And today we go to the moment where we are using complex algorithms to help us to take responsible decisions, and decisions that actually can accelerate the design process, accelerate the construction process, enhance the performance of the building. So the design tech is a motion of design, or like the motion of design that we are looking to include contemporary technologies, and maybe probably not only contemporary technology basically into our design processes, so that our buildings are they're just basically better.
Yeah. So you mentioned performance. So there are many ways of measuring performance, and it's basically of buildings. And there's a whole movement which is called performance-driven design, which basically promotes and pushes design which is based on hard metrics, which can be attached to environmental some environmental criteria. So what are the challenges? I know that you are one of the big enthusiasts about environmental design and performance-driven design.
Well, yeah, I mean, yeah, definitely. First off, I think that I think there was this group of people that we started using this we call digital technologies, the parametric design, etc., probably like 10 years ago, and we started to kind of exploring the possibilities of these tools, and then they were the possibilities were not that clear, but we're in the moment that probably Cedric Price would ask us. So we have technologies and answer. What was the question? And when we're looking for a very long time, what would be the question we are looking to answer? And I think that one of the most challenging questions that we we are looking to answer, we have been trying to answer, is how we can include this technology and this digital technology in architecture, this design tech, so-called, into fighting with the climate emergency, with the biodiversity loss, with this all the environmental crisis that we have been living recently. So I think that this is this set of tools that I'm working on, I have been developing recently, and I'm also basically helping others to kind of to include in their design processes, either it's academia or teaching or like professional life. I'm trying to include all this technology to make sure that the building has basically positive impact on the environment. Having said that, I'm totally conscious that we are looking only for a very small portion of. We don't have that much power as designers. I mean, I would be fool if I said that design can change world, and I would repeat what Papanek said in the 60s and 70s. I would just say that so everyone has their own battles, and this is our own battle that we are looking to fight, and we are fighting. And the real deal is basically policy making, that we can influence, understanding better how buildings are performing, and translating this information and creating this knowledge. So this could be a base for further policy making. And I think this constant feedback loop is super important, so that whoever is the actor in the design process, or in the entire life cycle of the building, we can have this information. And when I say information, probably most likely it's the digital information that is passing from one actor to another actor, from one stakeholder to another stakeholder, that we are passing this information back and forth, making a future building more responsive, understanding better the climate, understanding better the actual ways of living, needs of the users, and the resources, etc., etc.
Yeah, so that's super interesting. But can you give us a few examples of what are the metrics that we can actually measure when we and what are the tools that how do we do it? Do we simulate it digitally, or do we basically build a building and try to measure it in real life? What are the metrics?
Well, there are multiple. So if we're looking for the metrics that they are in, we're looking on the looking from the point of view of the life cycle assessment. So we're looking life cycles of buildings. So there are the metrics. The metrics are organized in impact categories. So the one impact category that we are tackling the most is climate change. It is the impact categories are related to planetary limits that have been defined by Stockholm Resilience Center in 2009. And this is one of the planetary limits is climate change, and we are looking on something which is called global warming potential. So we are looking how this building, or how its process is going to impact the global warming potential. And the global warming potential is measured in CO2 equivalent, which means how much carbon dioxide and other gases, like methane, for example, are being emitted to the atmosphere throughout the process of operation, construction, first manufacturing, construction, operation, and disposal or deconstruction of the building. So this is one of the impact categories, global warming potential, which is said that is the most important for the construction sector, since we're talking that in the EU, the construction sector is responsible for 36% of CO2 emission and about 40% of energy consumption. So this is a basically 36% means one third of the CO2 emission comes from the building. So this is the one we are focused the most. But there are other impact categories, like eutrophication, for instance, like acidification of oceans, depletion of freshwater resources, which are not that, which are less studied so far. So we are not that competent, or we are not that competent probably in applying this these categories into the and reviewing these categories and checking how they are, how was the relation with buildings itself. So firstly, we're looking for the carbon, and it lines up with the Fit to 55 package of the European Commission, that we need to cut the CO2 emission by 55%, at least 55% until 2030, and become carbon neutral by 2050. So this is the first step. It is important to say that we are getting here something which is called carbon panel, which means that we are only focusing on one planetary limit, which is climate change, and we're not taking other into account. Well, they are very much connected. I mean, this is like following the system theory. All the limits, all the elements are connected. So when there's one outside the equilibrium, that the other one enters out of the equilibrium. So we need to kind of make sure that we are looking on the other impact categories too.
Okay, so but those are quite high level categories, right? So, and
they're very high level categories. They are very high level categories, but they are very easy to measure.
And And are there any categories that which are maybe a little bit on the human level, right? So our perception or subjective ones, because that's also a very interesting topic. How do you measure things which are in theory very subjective, right? Like how well-being, for example, right? Can we measure it? Can we put a number?
Yeah, they are very high level categories, but they're critically planet-centric categories, not human-centric categories. And when we are talking, but they are high level, but they're translated very easy into the certificates and declarations and building operation, energy consumption. So if we're looking, for instance, for carbon emission and embodied carbon in buildings, so embodied carbon means that the carbon that is for the material, for the construction materials, it means how much CO2 was emitted during the process of sourcing, manufacturing, and transportation of the materials. So we can measure how much carbon was used. So how much carbon was used during the sourcing, for instance. And this is maybe but easier in the transportation. It's pretty straightforward. So how much transport was used, how much CO2 was emitted to the atmosphere during the process of taking the raw material from the mine, let's say, ore mine, to the factory that is melting the ore into steel. So we can measure basically how much CO2 was emitted during the process of transportation, and this is pretty straightforward. And the same if we look, for instance, for the operation of the building, we can say how much we can assess, or we can evaluate how much energy will a building consume for, I don't know, heating or electricity. And knowing the carbon mix of the country or carbon mix of the location, we can define how much CO2 will be released to the atmosphere in that process. So they are very high level categories, but we can drill down very, very fast. And if we know how to connect the dots, it is complex at the same time very, very simple. But we need to be very focused on that.
Yeah. So, but we've been of course building buildings for since the dawn of humanity, right? So what about the past technologies and current technologies? Shall we basically disregard everything and start from scratch and reinvent everything with technology, or are there some things from the past that are still valuable, and how do we merge this past experience with what technology allows us to do? And
I mean, yeah, that's a very nice question. I think the technology is a continuous process, and it was Louis Mumford that wrote this amazing book, Techniques and Civilization, that only has 3 chapters. The 4th chapter is missing because the book was published before the 4th chapter happened, so before the contemporary industries. And I think that the technology is very much continuous. We had this I would say, naive idea at the very beginning of modernism in architecture that we can kind of forget about whatever our ancestors talk about the relation with climate, and we can start building this kind of spaceships that they are going to go for. This is this glass shoebox in all the locations all over the world, regardless the climate, regardless the knowledge, the local knowledge, local materials, etc., etc. And I think this is this big mistake that started in this kind of strange moment in the 20s and 30s in the US with the rise of the international style. I think this strange beginning, of whatever we see today is a contemporary architecture, or most of the contemporary architecture is being now reviewed and understood better. So we are looking for this we are looking back to the vernacular architecture and vernacular technology, vernacular knowledge. What do I mean by that? So for a specific location, and if we for instance if we go to the southern Poland and northern Poland, for instance, we can compare how is the, I don't know, roof shape, let's say. So the roof shape in the southern Poland is going to be more steep because there's a lot of snow, and then we need this roof so it's not going, the snow isn't going to be so heavy and it's going to fall down. And in the northern Poland, the climate is milder, let's say by the sea, by the Baltics, and then we didn't have this concern that much. So the roofs were basically much they had a different angle. So if we start looking for this kind of very small characteristics that they are related with climate and microclimate, we can gain a lot of knowledge that happened in the past. So there is a part of Poland that we used to have a seasonal insulation. So there was a season in the winter time. So beginning in the autumn, they were putting. We were not doing that anymore. They were putting winter insulation, and then we are in the springtime. We are getting rid of this winter insulation system. So this kind of very small gestures and architectural features, passive strategies, allowed us to make our interiors better for living, and they didn't have much impact on the environment itself. Having said that, today, having all the contemporary technologies and tools that we are using, we need to kind of review whether each of the solution is basically good for the environment, for the indoor environment, and for the general environment itself, because many of the solutions came with fashion, so we don't know if they're good or not at all. We need to kind of review them. We can simulate, and we can see if it actually makes sense or not. That's first off, and second of all, we're dealing with this drastic climate change today, which actually alternated the weather patterns throughout the year, and the temperature is higher, the humidity. So we are having more this extreme heat waves events happening. So we need to kind of also make sure that this pattern that was coined for different climate or different motion or motion of climate, it actually reflects, or it will be good for the contemporary. I'm researching and working mostly in Portugal, and I know for a fact that the climate in Portugal, we have now 3 climate zones. Well, there are 3 defined climate zones, let's say so. There are many microclimates because of the sea, rivers, etc. But we are expecting that there will be only 1 climate zone, or maybe 2 climate zones in Portugal in 2050, following the IPCC scenarios. So now we need to kind of use this data that we are producing and use this past knowledge to get information for the future knowledge, the future design production.
So basically, all those technologies which are essentially pushing for more sustainable and greener buildings and environments are also like part of post-pandemic growth strategy, right? Like, so they are very much at the center of what the EU, well, among others, are pushing and promoting.
Yeah, definitely. The program, the Recovery and Resilience Plan, and this Repower EU. So we have this huge programs and Green New Deal. So this is like the third program, and inside of Green New Deal we have this new European Bauhaus. That there is a conference today in Brussels happening actually about that. We have these multiple programs that are happening on the European level. So the European Community level, and those programs basically are the answers for the pandemic situations. One of the important notion of these programs is digitalization and digitalization and this kind of information technologies answers. So we are not looking for the as business usual, design as usual solutions. We're looking for the innovation, and this is also one of the words that European Bauhaus is using next to something which is called invocazioni, which is or a very this is like this notion that's one of the members of the high table of the European Commission is talking. So it's not only of innovation, which is talking about the future, but we need to talk about also learning from the past. So this is like two different aspects. But definitely European policies are going in that direction. They are slow. The government is slow. The local applications of the policies is not very. It is very hard to. It is maybe not always, but often it's hard to how to apply the rules that they are coined on the high level to very local conditions, because Greece is way different than Norway. So this also, there is, apart from the faith, the endless faith in the European Commission documents, we need to have like this very strong local, regional policy making in terms of how to use this technology, how to include this technology that reflects also the development of the industries in each country.
Okay, so yep. I don't see any questions in the chat. Even if you have questions, please post them, because we still have, I believe, 7 minutes. But and if you have any questions which you want to take offline, please reach to us on social media. I want to maybe finish with last question, which I kind of get a lot, which with this rise of technology, AI, artificial intelligence, blockchain, you name it, right? Whether the role of an architect as a designer is a little bit under threat, whether we will be replaced by basically a machine which cranks out, all those perfectly optimized, number-driven designs which are perfect, whatever it means, right? And there is no like human touch and design.
Yeah, I mean, this is the discussion that we had already discussion beforehand, and I like this discussion because there's no answer for that, first off, and I believe that I think that there is the two levels of the discussion, that with the rise of technology and rise of this artificial intelligence, and with the idea of the singularity moment where the machines are going to be as smart or as intelligent as we humans, we are kind of hopefully looking for not working. So we are looking that we're going to be able to enjoy it, and machines are going to take over, and they're going to design and operate the environment for us. On the other hand, seeing all the smart cities, which were for a very long time, they were called smart city for dumb people. Then we moved to this idea, smart citizens, which is much stronger, much more, I would say, robust, and more responsible as well. This idea that, and many architects we do have, we still want to design, we still want to define. For now, what I'm seeing, and what I praise for, that we are using this technology to make better informed decisions. For me, one of the biggest problem is the amount and the structure of data we need to or we require to design a building that has all the levels on the complexity and the relations between different elements. I think that's the one thing that's for me that makes me to rethink this idea. And the second element is, who is the algorithm maker, who is the code maker, and who is putting the inputs, and how the inputs, who is deciding on the inputs. Because if it is like Cisco or I don't know, Philips, whatever company is taking the decision is for now it's based on the economical base. So this for me, then of course they are. I mean, you can use different thresholds, we can use different standards, we can aim for, I don't know, LEED, BREEAM buildings that they are so-called sustainable or less environmentally harmful. But then defining this set of rules, it's going to be, and I think it is going to be. It is not like, it is not it's going to happen. It's going to be a huge challenge for the community, and the community needs to realize that this is actual challenge for us, and that including the environmental crisis impact aspect, including now. I mean, we have been talking about the housing crisis since the 20s, basically, when we realized that there was a crisis, and beforehand, for sure, there was a crisis itself. So we have this multiple parameters, and we don't know how to put them. And I think it was Ernst May in the 20s that he said, we know what the house really needs is a 3 rooms, bathroom, and a kitchen, and we still cannot design a house. We are still reinventing the house. So I think this is, and then I read this probably like 5 years ago, and I was like, yeah, we know it, but we are still redesigning the house. We know all the parameters, but we keep repeating this exercise. And I'm sure that in your professional work, Marcin, you are having the same. I mean, you are asking, yeah, I'm doing the next, I don't know, probably a tower museum, a housing project, and we have the same set of parameters that input, and we're keep redesigning the algorithms because we cannot decide. We don't know what is our threshold, what are the outcomes, what are the expectatives. And I think this is super interesting. When I teach at the university, I see the students at the very beginning, they are not very enthusiastic about this notion of technology, and that technology is going to decide about everything. Then I see they're becoming very enthusiastic, and then they are becoming not enthusiastic again. So I think I think I had enough years of experience to say that we're like in this sinusoid going up and down, and we need to seriously start talking about that topic, and stop talking on this huge architectural events and biennales about the role of form and the role of rhythm in architecture, but we need to talk about the actual tangible problems that architecture can solve, that the architecture can be a machine informed machine for transforming our environment for a better place for living, not only for humans, but also for non-humans. That can be a machine to cleaning the air, to clean water, and to make the built environment a better place for all of us.
Yeah. So basically, as you said, like from my experience, more technology mean more work for us, but different, not less work. And I'm not afraid that will be replaced. Sure. Unfortunately, our discussion is coming to a close. We're running out of time. It's been a pleasure to host you and talk to you.
It was a pleasure. Thank you very much.
And I think that everyone who was not a geek about design and sustainability will become one after watching this. If you have any questions, please reach to us on social media. Thank you.
Thank you very much. Thank you very much for the invitation. Thank you very much for having me. I hope you'll enjoy all the rest of the days, and you will have a very nice afternoon. Ciao.
Thank you guys. Ciao.